Hello everyone, welcome back to Labtube. In this video, I'm going to solve question 18 from section 16.3, which asks this two-part question. Says the vector field is given, and it asks to find a function whose gradient is equal to this. And then part 2 says use that fact, part A, to evaluate this line integral of that vector field along this curve. Okay, what do I need to be able to solve this question? The first thing to know, that's actually something that you have to know for part A. Other way of saying part A is that the vector field F is conservative and find a potential. Find the potential means find a function whose gradient is equal to that vector. And the second thing you have to know is that line integral of a vector field which is conservative is easy to evaluate. If you have a vector field which is conservative, meaning that you can find a potential function for that, the value of that integral is that you find end point of your curve. End point is given by. Then you plug it in your function, potential function. Also do the same thing for initial point. You find the initial point, plug it in your potential function, subtract it. That's called fundamental theorem for line integrals of vector fields. Okay, so that's the general theory. For this specific question, I have to find a function whose gradient is equal to this vector field. This vector field is a vector field in R3, so my function should be a function with 3 variables. And by gradient, we all know that this is gradient of such function. And it should be equal to this vector field, sine y, x cosine y plus cosine z, and minus y sine z. Okay, so I have to find an f such that this gradient is equal to that. So that means partial derivative with respect to x is equal to sine y. Partial derivative of f with respect to y is equal to x cosine y plus cosine z. And partial derivative of function with respect to z is equal to minus y sine z. Okay, so I have to solve this system of PDEs, or just find such n. Okay, let's start with first equation. If I have a function whose partial derivative with respect to x is equal to sine y, what would be that function? The function itself. Okay? It is a function whose partial derivative with respect to x is sine y. This is constant. So that function should have this form. Plus anything which is constant with respect to x. So anything which is constant with respect to x. That means here I can have any function which is in terms of y and z, because when you find partial derivative, you consider y and z constant with respect to x, yes? So that would be the form of the function. Okay, if that's the form of my function, then that means I can differentiate this with respect to y. What would be the partial derivative of this with respect to y? It is going to be x cosine y plus partial derivative of this function, whatever that is, with respect to y. Okay, so that's very good. But I already know that partial derivative of f with respect to y should be equal to this. What does it say? It says that x cosine y plus cosine z should be equal to x cosine y plus cy. Okay, then I can cancel these two. That means cy partial derivative of, let me write like this. Cy partial derivative of that function with respect to y should be equal to cosine z. What kind of function that can be? So I have a function whose partial derivative with respect to y is cosine z. So then that means I have that form. But I can also have any constant, let me this time put d, any constant which is anything which is constant with respect to y, and it is constant with respect to x, so it can be any function with in terms of z. Okay, that's great. So then I can go back and update my function. My function was x sine y plus this function, yes, but now I know more about that function, y cosine z plus dz. Okay. This time, I can find partial derivative of this with respect to z. So partial derivative with respect to z. There is no z here, 0, plus partial derivative with respect to z, it is going to be minus y sine z plus d prime. Okay, but good thing is that I have partial derivative of f with respect to z given by this equation. That means these two are equal. Now, if you set them equal, this part is equal to that part, that means d prime is 0, that means d is actually constant. That means I can again update my function and put any constant here. Okay, steps lead us to this thing, that any potential function of that vector field would be of this form. X sine y plus y cosine z plus some constant. Okay, that's good because we solved part A. What about part B? Part B is evaluate this dr. Okay, part B is that then by fundamental theorem of line integrals, I know that if I plug in last endpoint of our curve in my potential function, so potential function is this, you plug in endpoint. Endpoint is the one you plug in pi over 2 here. So r pi over 2 minus plug in the initial point in your potential. So f r of 0. Subtract them. That would be equal to value of your line integral. Okay. So let's see what is that. R of pi over 2. R of pi over 2 means I have to plug in pi over 2 here. First component, sine of pi over 2 is 1. T, pi over 2. 2t, 2 times pi over 2 is pi. Minus, plug in 0 in this. F of sine 0 is 0. T at 0 is 0. And 2t at 0 is 0. Okay, great. Now I have everything because I have my function here. Plug in for x1, for y pi over 2, for z pi. So I have then 1 times sine pi over 2 plus pi over 2 cosine pi plus constant. The constant, whatever I put, they will cancel each other. Minus, plug in 0. If I plug in 0, this would be 0. For x, y, z, this would be 0. So I get minus 0. The answer is 1 times sine pi over 2 is 1 plus cosine of pi is -1, so I get 1 minus pi. So that's the value of line integral. Note that if you wanted to do this integral just by plugging in this in your formula, it would be a very long computation to get that number. But here, it was easy because we knew that the vector field was conservative, meaning that we can find a potential function for that. When you have that case, the fundamental theorem for line integral says that plug an endpoint in your potential function, plug an initial point in your potential function, subtract them. That is equal to your the value of the line integral. Have a great day, and thank you for watching this video.